Hello everyone, my name is Rushika Kishore Patole. I am a final year student of BTech VNIT Civil Branch. In this video, we will solve a problem regarding cyclic plate load test. This is the setup for the cyclic plate load test. The cyclic plate load test is a field test in which a load is applied to the soil and the settlement is measured. The cyclic plate load test is used to determine the allowable bearing pressure of a soil at a specified foundation depth. In this problem, we are going to find out sigma V1, that is effective overburden pressure, sigma V2, that is increase in vertical pressure due to weight of the block, total pressure sigma V, which is sigma V1 plus sigma V2, mean effective confining pressure sigma naught 1, the Cu1, that is coefficient of elastic uniform compression of a plate from cyclic plate load test, Cu2, that is coefficient of elastic uniform compression of foundation. To calculate the overburden pressure, the formula is sigma V1 is equals to gamma into B. Here gamma is given as 17 and B is given as 0.6 meter. So therefore 17 into 0.6, which is equals to 17 into 0.6, 10.2 kilonewton per meter square. So we'll write here 10.2 and here 10.2. This is in kilonewton per meter square. Now to calculate sigma V2. Sigma V2 is calculated by using the formula which is given in the problem, that is 0.3362 into P. So for the first case, the P is given as 100. So therefore sigma V2 is equals to 0.3362 into 100, which is equals to 33.62 kilonewton per meter square. And for P equals to 250, sigma V2 is equals to 0.3362 into 250, which is given as 0.3362 into 250, which is 84.05 kilonewton per meter square. Now to calculate sigma B is equals to sigma V1 plus sigma V2. So for the first case, sigma V equals to 10.2 plus 33.62, which is equals to 10.2 plus 33.62, which is equals to 43.82 kilonewton per meter square. And for the second case, sigma V equals to 10.2 plus 84.0 it is equals to 10.2 plus 84.05, which is equals to 94.25 kilonewton per meter square. Now we'll write here 33.62, 84.05, 43.83, 94.25. Now to calculate mean effective confining pressure, the formula given is 1 plus 2 K naught upon 3 into sigma V dash. So K naught given is here is 0.35. So it is equals to 1 plus 2 into 0.35 upon 3 into sigma V. So by after calculating, we get it as 0.57 into sigma V1. For the first case, the value of sigma naught 1 is equals to 0.57 into 43.82, which is equals to 24.97 kilonewton per meter square. And for sigma naught 1 for the second case, we calculate it as 0.57 into 94.25, which is equals to 53.72 kilonewton per meter square. So we'll write it here 24.97 and 53.72. To calculate Cu for the plate, so the formula given is P by SE. from the from the table the P given for here is 100 and the AC given here is 2.8. So P by AC is equals to 100 by 2.8 into 10 to the power minus 3 to convert it into meter. So which is equals to 100 by 2.8 into 10 to the power minus 3 is equals to 35714.28 kilonewton per meter cube. This is for the first case. For the second case, P by S equals to 250 upon 6 into 10 to the power minus 3, which is equals to 250 upon 6 into 10 to the power minus 3, which is 4166.67 kilonewton per meter cube. So right here 35714.28 4166.67. To find out the elastic uniform compression for foundation, the formula is Cu2 by Cu1, which is equals to sigma naught 2 by sigma naught 1 to the power 0.5 into A1 by A2 to the power 0.5. Here we take sigma naught 2 as 10 and the area of foundation we take it as a 10 meter square. The area of plate we found it as 0.6 into 0.6, which is equals to 0.36. So therefore we obtain Cu2 as Cu1 into under root of 10 into 0.36 upon sigma naught 1 into 10. For the first condition, Cu2 is equals to 357.14 into under root of 10 into 0.36 upon 24.97 into 10, which is obtained as into 100, which is equals to 357.14 into 100 into under root 0.36 by 24.97, which is equals to 4288.25 kilonewton per meter cube. And for the second case, Cu2 equals to Cu1, which is 4166.67 into under root 10 into 0.36 upon 53.72 into 10, which is equals to 4166.67 into under root 0.36 divided by 53.72, which is equals to 3410.92 kilonewton per meter cube. And now we write it here as 4288.25 and 3410.92. This is in kilonewton per meter cube.